When we write Boolean expressions, we can include logical operators. One logical operator is called and we write this using two ampersand signs like this. We use this with a Boolean expression on either side. So this creates a compound Boolean expression, meaning we have two Boolean expressions joined with a logical operator. So we can see an example of this here. We have two Boolean variables, one set to true, one set to false. And then we have a compound Boolean expression, which uses our AND operator. So we say Boolean B3 gets B1 and B2. So we have to evaluate this expression to determine the value of B3. The AND operator requires that both sides of the compound expression are true in order for the entire expression to be true. So that means both sides, B1 and B2, would have to be true in order for this expression to be true. But in this case, B1 is true, but B2 is false. So that means that the entire compound expression is going to evaluate to false. So B3 gets the value false. In this table, you can see the different options for inputs, so the left side and the right side, and what the result or the compound expression would evaluate to. So if both the left and the right side of the compound expression are false, then it will evaluate to false. If one is true and one is false, as in these two rows, then the result is also false. And the only way to get a result of true is if both the left and the right side are true. So when you see a table like this that shows the possible inputs, includes all possible inputs to an expression, and then what the expression will evaluate to, we call this a truth table. Another logical operator that we use is the OR operator. So this is two vertical bars, like you see here. To get those vertical bars when you're typing, you hold down Shift and then press the backslash button, which is right above Enter or Return on your keyboard. So here we have another example. We have our two Boolean variables set to true and false, and then our Boolean B3 gets the value of B1 or B2. So we're going to evaluate this compound Boolean expression that uses our OR operator. And if either the left side or the right side of the compound Boolean expression is true, then the expression will evaluate to true. So in this case, B1 is true. So the entire expression is going to evaluate to true, even though the right-hand side, B2, is false. So B3 is going to get the value true. Here is our truth table for the OR operator. So if both the left and the right side are false, then the compound expression evaluates to false. If either side is true, so if the left is false and the right is true, or the left is true and the right side is false, then the expression will evaluate to true. And if both sides are true, it will still evaluate to true. Another logical operator is the NOT operator. So we write NOT as an exclamation mark. So we can see a couple examples here. If B1 or Boolean B1 gets the value true, and then we say Boolean B2 gets the value not B1. So that negates this expression, so it takes the opposite of it. So the opposite of true is false, so B2 gets the value false. We can also use our NOT operator with comparisons. So here we're going to follow our order of operations, do what's in the parentheses first. So we evaluate 4 less than 3. That is false. And then we're going to use our NOT operator. So not false is true. So B3 gets the value true. So going deeper into our order of operations. AND takes precedence over OR. So we do all the ANDs in a Boolean expression first, and then we go back and do the ORs. So in our example here, we have integers x and y, and then we set our Boolean b to have the value of this compound Boolean expression. So we're going to go through and first we evaluate our comparisons. So we have to evaluate, is x less than y? That is true. We're going to leave our or alone for now. We evaluate, does x equal 4? So x equals 4 is asking if x equals 4. It's not changing the value of x, it's asking, is x equal to 4? And that is true. We're going to leave our and alone for now, and we're just going to evaluate, is x equal y? That is false. So now we've got this simplified to true or true and false. So the next step is to evaluate all the ands in this expression from left to right. So we find that we just have one and operator, so it's saying true and false. Since both sides are not true, this is going to evaluate to false. So true and false evaluates to false. So now we've simplified this to true or false. And since at least one side of the or operator is true, the entire expression evaluates to true. So and takes precedence over or. Now if you were writing this code, you could add some clarity to it by adding parentheses. So this is the same expression, and it still evaluates to true. We're not changing any of the logic. We're just adding clarity by putting our parentheses here, just to emphasize that we're going to evaluate the and part of this first, and then we'll do the or. So it's not changing the outcome, it's just making it more clear what we are trying to do.